Dear student, in this video we will see how to design a controller. Here we will discuss to the design aspects we are going to use. So this particular feedback structure, how to design a controller. So design this particular controller, there are so many approaches which are possible. Some of approaches we will discuss here. The first approach is experimental approach. In this approach, install a controller based on the experiment or based on the experience. In this particular approach, first we have installed a controller based on the experience. Practical experience on the process of the plant. This particular controller which I installed, there is certain parameter of this particular controller which I can adjust online and see and get the parameter, so that the control variable is follow the command to an accuracy acceptable to the process engineer or user. This particular experimental design is referred to as controller tuning. This is the method which is extensively used in process control application, because the requirement there, first one is the information about the process is not available so as to model it accurately. It is a highly nonlinear process model, and therefore instead of relying on quantitative information about the process, we rely on the experimental knowledge about the process, about the operator experiences, about the process, installed a controller and tune the parameter of the controller so that an effective tie-up between the control variable and the command signal is achieved. A process known as controller tuning, and I may say that this is known as ad hoc approach of design. The next approach is model-based approach or analytical approach. In this particular approach, why I need this approach? If the requirement of controller high, or if the system is too complex to be tuned using the ad hoc approach, in that particular case, I will like to go for this approach. So what I do this particular approach? In this approach, we capture the dynamics of the model in a suitable mathematical form. It may be a differential equation, or maybe a transfer function, or maybe a state variable model. Once we find this mathematical model is available, we are more knowledgeable about the characteristics of the system quantitatively, and this quantitative information is used to design a controller using analytical method of design. So once I design such a controller using this method, and I hope to get, or I do get, better control on the system. Now we will discuss the third approach in the next video.